Hello everyone, welcome back to our YouTube channel. In this video, we're going to be looking at what exactly function overloading is. Now, to get into function overloading, first let's recall a few concepts about functions. Now, we all know that we can create user-defined functions, and we can call these functions by calling the identifier followed by brackets and any extra parameters we need to pass it. But now, let's say, for example, I had to create a function that would add 1 to a variable and return the new value back. Now, let's say, for example, we got a string. Let's say the user entered a string into our function. Then we would have to call the function to the left, public string add string s, and then you return the value of the integer parsed string with the number added to with one added to it. But if the user input an int, then we could simply call the function to the right. Now, let's say, for example, the user entered a float. We'll have to create another function for that. And just like that, for every single data type, we'd have to create a function. Now, this obviously seems a little redundant, doesn't it? Maybe we could address this by creating one function called add and adding else if statements to it. And this else if statement will check if the value that is entered into the function is a string or a num or an int or a float or a double, etc., etc. But now the problem over here is that our functions can only return one value, and we have to specify the data type of the value that we're returning back. In the function add string to the left, we know that we're going to be returning a string. In the int function to the right, which is add integer, we are returning an int value, and we know this. But if we created an else if statement, or we created a function with an else if statement, then we wouldn't exactly know which value we're returning back, the data type of the value that we're returning back, because we don't know what the user is inputting. And to do this for all of these data types, it would make our code so much longer than it has to be. And this is exactly the two problems that gave rise to the concept of function overloading. If we had a function that could take in all data types like string, integer, float, double, we'd have to deal with all of these using else if statements, but that would just make our code so much more complex and harder to read. Not to mention, it would make it kind of unreliable because we don't even know which data type we're going to be returning, and that is something that we really do need to know. But now let's take another example of if we were writing a huge program. Like, let's say that you were a coder at Google, and something like a search engine like Google has at least a million functions which have different names. And to try to remember or to recall the function that takes in a certain data type as its argument and returns a certain value will be extremely difficult. And so to counter this, we make use of function overloading. Now, I've kept saying function overload. We need to use function overloading. We need to use it. It's much better this way. But what exactly is function overloading? Function overloading is basically when two or more methods in one class, methods or functions, share the same name. Like in the example given below, the two functions share the name add, but they have a different number, type, or order of arguments. Then these two functions are said to be overloaded, and this concept is known as function overloading. Let's look at the first function, the public string add string s. Now, if we look at it, the argument that we're sending inside is of string value. While if we look at the function below that, which has the same name, it has an int value inside of its arguments. These things are enough for the compiler, and we'll get more into that later. But we can see now that we don't really need to remember add string will return a string with one added to the number that we passed inside, or the string value that we added to inside of it. And we don't need to remember that we need to call add integer and pass in int is as the argument. So this makes our job much easier. All we need to do is call a function add and put and pass in a certain data type inside of inside of the parentheses, and a function will be run and we'll get the proper return value. So this deals with both of the problems that we mentioned over here. It makes sure this code is so much more readable than if we would have else if statements, and it's more viable too. And we won't need to go through the process of having to remember different function names like add string, add integer, etc., etc. Now, some things to remember while we're using function overloading is that the Java compiler only looks at the function signature. So if we look at this code over here, public void add int num is what we're receiving as parameters, as a parameter. Sorry, yeah, as a parameter. And we system.out.println the value of num plus one. And obviously over here we have a different return type. We have void over here. But if we go down, we have public int add int num, and this function has a return type of an int, and it returns num plus one. Now this would actually throw an error because the function signature only consists of the function name and the arguments, and not the return value. So even if we had another function which was public string, which returned a string, and add and had the name of add, but received int as its argument, then the function would throw an error because there's another function which has the same name and the same arguments. So now function overloading is also a way in which polymorphism is implemented in Java. Now polymorphism is something that there's another video on polymorphism, so you can always check that out later. Now another great feature in Java is that the compiler implicitly converts certain variables to its closest data type. Now, let's say, for example, that we used this example, right? And we call the function add, and we passed in a variable of short data type. The compiler would actually implicitly convert the short into an int value just so that this function can be run. So we don't really need to write different functions for different data types. But if it comes to something like double, and we're passing a double into a function into a function that takes in an int, then it will obviously lead to loss of data. So we might want to be careful there. Now, one common example that we all use is system.out.println. This is an overloaded function, and it's one of the best examples of an overloaded function. Inside of the parentheses, we can pass in a string value, uh, we can pass in an int, we can pass in a float, we can pass in a double, and the function always works. But let's say, for example, function overloading never did exist. Then we would have then instead of system.out.println, functions would be like system.out.print string, and then put a string inside of it, system.out.print int, and then you put the int value inside. And this way we literally have to remember 10 different functions for the same purpose, which is to print a certain value. And that's another example as to how function overloading makes our life that much easier. And with that, you're now familiar with the concept of function overloading, and you can now use it in your Java programs to make much better and more efficient and more readable programs. Thank you, and don't forget to like, share, and subscribe if you liked the video.